Let's talk about atoms, molecules, and ions from Chemistry 101. I'm going to teach you how to identify proton, how to identify nucleus and electrons. So, let's start. We can assume that like an Olympic stadium, we can call that Olympic stadium the atom, and we can call the nucleus the tennis ball on that stadium. Proton is always positively charged. What do I mean by that? A proton, which is P, is always positively charged. That's the first thing you need to know. Then we also have neutron. Neutron, which is N, is always neutral. It's always neutral. That means the charge is always equal to 0. And electron, which is the last one, which is E, is always negatively charged. So you just have to have all this in mind. Proton is always positively charged. Neutron is always neutral. That means the charge is always equal to 0. And electron is always negatively charged. Then let's talk about the atomic number, mass number, and isotopes. What are atomic numbers? Atomic number is the number of protons in a nucleus. That means the number of protons in the nucleus is called atomic numbers. If we have 10 numbers of protons in the nucleus, that means the atomic number is equal to the protons, the number of protons in that nucleus. What do I mean by that? The atomic number, let's call that Z, is always equal to protons. Then mass number, let's call that A, is equal to the number of proton plus the number of neutrons. Don't worry, I will still explain better. We still have so many examples regarding this. So now, let's assume that we have a variable x, and this is our A, which is the mass number, and this our Z, which is the atomic number. This one is the mass number. This is the atomic number. So you have to have this in mind whenever you see something, even if it is chlorine, if it is sulfate or anything you see, you have to always have it in mind that anything that is here is always the mass number. Anything you see here is always the atomic number, which is equal to protons. So this thing here, this Z, is the atomic number and is also equal to protons. You have to have this in mind. So let's talk about some examples. Let's solve some examples. The first example I have here with me is we are asked to give the number of protons, neutrons, and electrons in each of the following species. We have to find the protons, neutrons, and electrons. We have sodium, the number of proton, like I said earlier on, the number of proton is equal to the number of the atomic number there. So this is our proton here, and this is our mass number. Now our proton here is 11. The proton is 11, and which is also equal to the atomic number, and the mass number here is 20. The mass number here is 20. So to find our neutrons, we have to subtract the mass number minus the atomic number. You have to have this formula in mind. Note, neutron is always equal to the mass number minus atomic number, or you can call it protons. So here we have, this is the number of our proton, and this is our mass number. So to find the neutron, we just subtract this from this. That's 20 minus 11, which is 9. And the number of electron is the same as the number of proton, which is 11. This is another thing you have to have in mind. The proton is always equal to electron. Yeah, so that's our first example. And the second one is the number of protons here is still 11, because we have 11 here. And neutron is this minus this, which is 22 minus 11, which will give us 11. And the number of electron is always equal to the number of protons, which is still 11. Now, another example. We have O. this oxygen, 17. We are only given the mass number. So they can give you this type of question. So what you need here is to check the table. We use a table to find the number of protons sometimes. Here we are only given the mass number. So if you check the table, the proton of oxygen is 8. I don't have the table here with me, but it's always 8, the number of protons. The protons in oxygen is always 8. So we have 8 protons there. So here we now have 8, and neutron will be 17 minus 8. 17 minus 8, which is 9. And the number of electrons is equal to the number of protons, which is 8. And the last example here is this, what is given. The last example, we are given carbon 14. This is what is given. So for you to find this, sometimes they give you this type of question to confuse students. It's still the same idea. So what you just have to do is to transform this to normal way they write it. So yeah, we can write this one as carbon 14. We can write this as this. Sometimes students write 14 here, and that's not right. You have to write it at the top, because this thing is the mass number, not the proton or the atomic number. So we have to write it at the top, which is 14. Then we need the table again to know the number of protons that carbon has. Carbon has 6 protons, or atomic numbers. So to now find the number of protons here is 6. Number of neutron is 14 minus 6, which is 8. And electron is always equal to proton, which is 6. So that is the example I have here with me. Please try and get the table so that you understand it much more better. So what have I explained so far? I talked about protons, and I talked about neutrons and electrons. If you are given any element, like here sodium is given, have it in mind that proton is always here, or the atomic number. You can call it atomic number or proton. And have it in mind that the mass number is always at the top. And always also have this formula in mind. Neutron is equal to the mass number minus atomic number, or the protons. And proton is always equal to electrons. And if you are given something like this, you just have to know that you have to put it at the top. What is given here, this 10 here, this 14 here, is our mass number, not the atomic number or the proton. This is always the mass number. And also, I talked about the charge of proton, the charge of neutron, and the charge of electron. The charge of proton is always positively charged. Proton is always positively charged, and neutron is always neutral. So it has no charge. It's always 0. And electron is always negatively charged, which is always negative. So I think that's all for this video. In the next video, I will solve some examples about protons, neutrons, and electrons. Thanks for watching.